Thank you, Professor Chen. So yes, we go way back. We're friends. So if you see us being very like informal with each other, it's because we've known each other for a long time. Um, but I've been teaching research methods, as she said, for a very long time. Not all of my students are as fortunate as you guys to have SPSS, either through the school or be able to buy a license. So when I started teaching this class way back when, it was without SPSS available either not just to me, but for my students. So I could get a license for a teacher, but not my students. And so I had to come up with a way for my students to do their statistics, not by hand, because that would just be too long, but a way that they could do it, which promoted equity, which means, you don't have to have money to buy it. Everybody has access to it, but also something that is easier. Some students like SPSS, but sometimes they forget how to do things. And then also, something that will add to your toolbox. So I like to talk about my research methods. In research methods, you have a lot of tools. You have a lot of ways that you can go about gathering data. And one of the skills you learn in research methods is to do analyses on like something like Excel or using SPSS. So given that you guys should know how to use SPSS already, I wanted to give you this option. And this is something you can use if you ever lose your access to SPSS, or if you want to do something really, really quick and you don't want to open up SPSS, or if you want to show a friend who might not have SPSS how to do statistics. Originally, like Professor Chen said, we were going to do Excel, but this is even, I think, more equitable because you don't actually have to go into Excel or download or have an account. You could just go to this web page. And it does have, I think, in my opinion, some advantages. And I'll point those out along the way. So if you want to access this page while I'm talking, that's fine. But I definitely think you should just watch first before you attempt to do anything. And then I think she sent you the Excel file that has data in it. It's a sample Excel file. It actually is real data that I've collected in the past. So I'm going to use that data into the tutorials, and that way you could replicate the same steps and get the same answers. So what if you did your results with SPSS and you wanted a way to double check that? You could use this to double check that if you wanted to. I just think it's important for students to have lots of different ways to get what they need. So this is a free way, but you do have to have some statistical knowledge, because research methods is not the class that Professor Chen is teaching you the theory behind the stats. Her job is to remind you what statistical formulas are out there, which ones would be appropriate for your variables, okay, and which ones you would use in the class. So you might not use all of these that are on the calculators, but again, when you ever feel like you want to try it out for, let's say, a future assignment, a future class, a future project, you can. So this does not in any way replace SPSS. It's not as robust. It doesn't have all the same functions, but I think for an undergraduate research methods class, it is a good supplement to that. But it's like Professor Chen said, somebody asked if you can use this. Not that should you, it's really good. Like she said, it's up to you. You should use SPSS if you feel you're comfortable, you know your way around that. If you feel like you want to learn something else, try this. But I know Professor Chen, she's not going to force you to do something if there's multiple ways to do it, but you should always follow directions, right? So this is just added to what you have available to you. If you ever want to learn how to use this Excel for statistics, I don't know if we'll have time today, but at a future date, what I could do is we could do another meeting. I could drop in for another meeting, or I could share some of the videos I've made for my classes. Probably they're about a year old now, so I can always share those with her, and then she can share those with you. Okay. So if you are looking at the screen, it should be the web page that we're going to use. It's free. It's on the home page. You can read about like what it has available. So that's what you should be seeing. I like to go to the statistical calculators link. That's always the first place I go. So either go from the home page here, or I go up here on the tab that says calculators. It also tells you here, if you don't know what you're using, which statistics test you need to use, you can use this tutorial, but you should always double check, because it's not able to recognize any exceptions to the rule. So I would first figure out what tests you need to use, and then go about clicking on the link. Okay. So I believe that, and Professor Chen will correct me if I'm wrong, that most of you will have to run what's called a correlation analysis. So if you're looking at this list here, all you have to do is scroll down till you find it. Okay. And it might not be in alphabetical order. I actually think it's in alphabetical order, but it might be also grouped by the type of test. So here, if you guys scroll down to about the middle of the page, you're going to find different kinds of correlations. The one that we use in statistics, like 99% of the time, is the Pearson's R. So it's this one here, the Pearson correlation coefficient calculator. Once in a blue moon, you might use what's called the Spearman's ranked one. But that, again, that would be only if your variables are ranked. So like on a scale of like a rank, an ordinal measurement, a variable that's measured with an ordinal level is ranked. Like on a scale of 1 to 5, how would you rate this movie? Okay, or how would you rate this meal or this restaurant? So I would say, unless you for sure realize that your variables are ordinal level of measurement, then you could use the Spearman's ranked, but 99% of the time you're using this one. It's a Pearson's R, it's a bivariate correlation, or sometimes just called a correlation coefficient. So it's really general in that sense. Okay, so let's just scroll down to see some other things. If you actually have the p-values of your results, it'll actually down here, it'll actually, if you want to get p-values, like if you have the correlation but don't get the p-value, you could use these calculators down here. And I believe I might have skipped it. There should be ones for like mean, standard, and mode, and standard deviation. There should be one for all your descriptive statistics, so we can take a look at that later. Oh, it might be up here, sorry. So here's the actual calculators for inferential statistics. You guys should know the difference, right, between inferential and descriptives. So if you need a quick way to also run means, standard deviation, you would go under this tab. So I just clicked on the descriptive statistics tab. Here you can put the scores in to get mean, median, mode, variance, and standard deviation. Actually, let's start there, because you should always give the measures of central tendency and variation, and that helps you to determine whether your distribution is normal, right? So one quick way to tell without plotting the distribution is to actually calculate the mean, the median, the mode, and just look at it and make sure those numbers are close together. So what I mean by that is, if you were to calculate, let's say you take one of your variables, one of the ones that I have in Excel file that Professor Chen should have given you is abbreviated RSES. That actually stands for Rosenberg Self-Esteem Scale. So those numbers are actually student scores. So what you would do is you would take that whole column, you would dump it into these calculators and get the mean, the median, and the mode. And then we would look at the values to tell if we have a normal distribution. Sorry, it took a while for it to load. So it could be either my connection or the website. It's probably mine. You guys know, if you're in my class, I think I saw some familiar names. Sometimes my internet goes out. Okay, so make sure that if you are, that you're using quantitative measurements. I don't suggest this for any nominal or ordinal. I would suggest only using this calculator if you had numerical data. That's what I think it's best for, but you can try out these other ones. Okay, that's not it. I need to copy over. So give me a second. I'm just going to copy over the data from the Excel file that you should have been sent. And I'm just going to copy over the column that says RSES if you want to follow along. Again, that stands for Rosenberg Self-Esteem Scale. So some of you may be using that for your project, which is great. It's easy to score. And this is real data. So you do one variable at a time, and you just copy and paste it in here. Make sure though, don't do what I did, because I think I copied the label. See that, the RSES? You don't want to put letters in there if the rest are numbers, and vice versa. So everything should be consistent. So I think you just copy and paste, and that should be all the data. And then we're going to go ahead and calculate it. Okay, so if you see that I'm scrolling down, I'll go ahead and hit the calculate button. Hopefully there's nothing that's going to throw the calculator off, like a missing value, a letter in there, or a symbol that's not supposed to be there. It's taking a while, guys. Oh, there we go. Okay, did you see how it popped up right below here in blue ink or blue font? Sorry, it's not a piece of paper. But the mean, the median, the mode, those are the values. And if we are doing statistics, you guys, in statistics, we always report to the third significant figure. So for example, this mean score, if you were to report it, would be 22.7. We're going to round off, okay? The median score is 23. If there was a decimal number there, you would report that. The modal score 27. If there was, you would report that. In some cases, if you have a whole number like this, you can just put 23.0 and then 27.0 if you're using three significant figures and you want to be all consistent, okay? You might be tempted to put 20 for the mean, 22 because you're rounding up, but remember in science, you have to be precise. So you rarely round up like that. In this case, it would be more appropriate to report the mean score. And this is for the Rosenberg self-esteem scores, 22.7. So you would round the 0.6, but you wouldn't round it to 23, okay? Now, this is I would say 23 is about higher than the average score on self-esteem, which means they have a more positive view of themselves overall. And that's hopefully what you guys are going to be doing for your project. Measure something, a variable that's abstract in someone. You can't just see it by looking at them. You get that data, you answer, they fill out those questionnaires, you score it, then you look at the data using these formulas, and it gives you a better sense of what the data is trying to tell you. So in this case, the mean score is above average. The highest score you can get is 30. And these college students overall have a general view of themselves that is positive. Now, earlier when I said, how do you know this is normal distribution? The mean score, which is 22.6, the median score, which is right in the middle of the data set, is 23. The modal is a little higher. The most frequently occurring score is 27, which means there's a lot of people in this data set that have almost the highest score you can get, have a higher than average self-esteem score. But if you just look at the numbers themselves, a quick and easy way to tell if this distribution is normal is if the mean score, the median score, and the modal score are almost the same number. So 22.7 is similar to 23. It's not statistically different or significantly different. 27 is a bit high, but you can take, I usually just take the mean and the median. Usually I just take the top two numbers. I subtract them from one another. And what you're left over, if it's close to 0, so if you subtract 23 from 22.7, you just have 0.3. If it's close to 0, that means it's likely a normal distribution. But I would say that if you did that and the number was quite high, you may have some outliers that you may want to either extract from your data set. It's not that you're fudging the data, it's just that sometimes outliers, that's what they are. Someone's not paying attention, or they're just clicking your survey without reading. So if that's the case, but I always tell my students, and again, this is whatever Professor Chen says goes, as long as it's pretty close, like 22.6 in my mind is pretty close to 23, I think I'm good to go. But if you strongly feel like your data has a lot of outliers, you can talk to Professor Chen about what you guys want to do with that. In my case, if I have a lot of data, if I have the more than 30 that is needed, then I do look at outliers and I would take out that entire person. So not just that dot, but the entire person. Maybe they weren't reading, or maybe they were lying, or maybe they're just being honest. So I don't think that's as big a deal. But I would say that, just pay attention to that. You can plot it. I think here, the only drawback is that I would prefer that you guys learn how to plot your data in SPSS, because if it's already in SPSS, or you can use Excel. I think the plotting functions here are not as great. Okay. But I still think it's possible. So if you just really quickly, you guys, you could do this in Excel as well. Excel is so easy. You could always search for videos to find the mean, median, and modal scores of a column of data. Okay, so if you want to practice doing the same thing, if you grab the other column in the data set, which is abbreviated NPI, which stands for Narcissism Personnel Inventory. So these are students' narcissism scores on what's called the NPI, and you can Google that. It's 40 questions. The higher the score, the more narcissistic students report. And the reason why I wanted to look at that in conjunction with the Rosenberg self-esteem scale was that people who have an overall positive view of themselves, the higher they are, the more likely that they could also score higher in narcissism, because that's part of that's a domain of narcissism, a positive view of oneself. And in this case, narcissism is like an inflated view of oneself and an excessive form of self-love. So you would assume that if someone is has a very positive view of themselves, that's like positive self-esteem, but they could also fall into narcissism, which is that excessive self-love. So we could look at both. They're not the same thing, but there's going to be some overlap there. So you could then, I just put the data in from the NPI, and we'll just hit the calculate button again. And then it changed. So the mean score here, 38.7, 40 and 44, a little bit more discrepancy. There might be some outliers here, maybe someone who's really high in narcissism, someone who's really low. Again, we could take them out later, but there you go. That's like really quick how to do mean, median, mode, and you could use that to tell normal distribution. Okay, now let's get to the correlations, because that is more important. Okay, so when in doubt, you guys, you could use Excel to find mean, median, mode. You could just do it by hand. You could use a regular calculator. The one thing that I always tell my students about statistics, and of course, if you already know SPSS, you guys know how to find that fairly easily. It's just a couple of clicks, right, on the drop-down menu. Don't ever let technology stop you from doing your data. Don't ever let it stop you from running any of your calculations. When in doubt, if you need to do a mean score by hand, do it by hand, okay? If you ever need to do anything, and try Excel, try SPSS, try this. You should never email your professor and say, I don't know how to do XYZ, especially if you've been shown, or especially if you've taken statistics before this class. So it's not an excuse to ever say, I couldn't get SPSS. Well, what about this website that we're showing you today? Well, my internet was down. Well, what about Excel? There is no need to run Excel on the internet unless you are running it off 365 or Outlook and didn't download it. So if you have access to Excel through your Laverne account through 365, download the app version so you can run it as a stable app and it doesn't have to be online. Okay. So I'm trying to go back to the descriptive statistics page. And also, again, if you want to do the variance and standard deviation, go ahead.
I haven't told them yet, but for your projects, your surveys, you're going to be getting 30 participants, but you might get more depending on how many classes I offer it to. You might get something like 80 participants, but you don't need to do all 80. Like if you want to just close, if you reach your 30 and you want to just close off your survey, then you can just do that. You don't need, you don't need like 80 or 100 or any of that. So if you did need to do mean, median, mode by hand, you totally could.
Yeah. Okay, so I just went back to this one and I actually chose the standard deviation calculator. This is sample. You guys are calculating sample data, not population. The difference would be population is everyone in the group that you're interested in. You guys are doing small groups, minimum 30, so that makes it a sample instead. And so make sure to click that because the parameters are a bit different. And there you go, there's your standard deviation. This is for narcissism, the MPI scores. So you'll see that 7.2. That's kind of high. There is a lot, it seems there's a lot of variation. You might have some outliers. But going back to what Professor Chen was saying, that is true. You might not need to use all the data you get. I always encourage my students to collect as much data as they want. I actually don't ever tell them to close off their survey unless they are ready to move on to the next step or they are pretty much done with everything, because here's what I think is important. You can always collect data and you can always just take a chunk of your data to look at, let's say only 30 of your 50 participants. But what if some of those are outliers or you have to get rid of them for whatever reason? You have those extra 20 to pull from, right? And so the rule is in my classes, you should always have more data than you need, because you can always ignore the data if you have 30, the first 30 that come in, they're great. You don't have to use the remaining 20 or 30 that you get. But if you only get 30 and you have to throw some out, then you're at 25. You're going to decrease your chance of finding significance. So I do think it's important to close your survey when you're ready to do your analysis so you don't get confused about stuff that's coming in. But I want you guys to be careful and don't make the mistake of shutting off your survey before Professor Chen tells you it's okay. Because what if you end up throwing some of those out? So the rule in science, it's always best to have more data than you need. It's always better to ask more questions than you will look at in terms of the data. But it's important to, yes, to be precise and not just pick and choose stuff in terms of, oh, I'm going to pick this line of data over this line. So it's really important that you guys always check in with her before you do something that, you know, especially that could have ramifications for later. Okay. Although this is an independent research project, you guys should be pretty, you know, you should have a lot of control and have a lot of autonomy. But you can always ask questions when you're in doubt. Okay. So if we went back to the statistical calculators, it's very likely that you're also going to use a one-way ANOVA. So if you have questions, you could put in the chat, and then if you want, you could unmute yourself. A one-way ANOVA, you're probably using the independent measures, and this is for when you have 3 or more groups to look at something. So it's still one variable, but you have 3 groups to examine the differences. So Professor Chen mentioned that you guys want to do things with pets. So let's say we had the self-esteem scores for people with pets, and we have one group with the cat owners, the other group with the dog owners, and then maybe a group with both, because maybe you want to look at those differences. People who have just cats, people who have just dogs, and then people who have both cats and dogs. Or you could add, you know what, if it's like a snake or a reptile or bird, a fish, right? So you could have 3 or more groups, and you want to look at who has higher self-esteem levels or lower. So you could do that. You could look at the differences between 3 or more groups if you use a one-way ANOVA. Okay. But I'll go back down to the correlation because that's where we started. And I would say if you really want to do a linear regression, you could do a linear regression. But I'm going to start with the most basic. Okay. The Pearson's R. So the only difference is I'm clicking on it, and it's just going to take a while because usually when you share your screen in Zoom, sometimes it doesn't recognize that you're clicking on the screen. Okay. So here, what I like about this website is that it tells you what a correlation is used for. Okay. And it gives you the standard formula, which in this class, again, you're probably not getting tested on, but you should still know why is a correlation. So this measures the linear association between 2 variables, but which kind? Numerical, interval, or ratio. Okay, so we don't use letters in here whatsoever. And if we have a ranked or ordinal variable, we'll use another one. So this data should all be quantitative, okay? And it reminds you that R equals 1 means a perfect correlation, which we're probably never going to have, okay? But it reminds you of that restriction of range, -1 to +1. If your correlation exceeds 1, something went wrong. It should never exceed 1. So remember that restriction of range is really, really important. Okay, it also gives you an example. In this case, it's not psychological, but if people are taller, they also might weigh more, right? That's actually where, and this, if I have any of my history of psych students in here, Sir Francis Galton started by plotting out the weight and the height of participants, of people, and the height of like fathers and sons, and then he moved on to IQ, right? And remember, we learned in history of psych that he wanted a way to measure the connection between 2 data points, 2 paired data points. And he tasked his really good friend and also former student Carl Pearson with developing the formula. And he was also Sir Francis Galton's biographer. So he asked Pearson to eventually come up with the formula. So Galton himself didn't make up the formula, he had the idea of it. There should be a mathematical way that we can examine paired data, and that if we know one, we could figure out the other one. And we could first see if they go together. So if I'm taller, do I also weigh more? And then also plotting, he did the height of the father with their sons and then eventually the IQ scores. So are they related? Are they connected to each other? Oh, my internet's unstable. Oh my God, hold on. I'm gonna get on my hotspot just in case, because you guys, if you've been in my class, you know this happens. Hold on. Turning on my hotspot just in case. Okay, and then if it locks me off, I'll just get back on. Now, go to the Excel file if you want to follow along. You just need to have 2 variables to do a correlation. that's minimum. You could do more than 2, but you should only do 2 at a time. This is very similar to plotting dots in a scatter plot because it's paired data. Doesn't matter which one you put in X or Y. So this is just a correlation. We're just looking to see if 2 things go together. The only difference it would make where X and Y are, like, you're very precise about which one goes to which column, is when you run a regression, because you're saying one is the cause, the other is the effect. So for this, it doesn't matter which column you use. You just put one variable into one column, if that makes sense. Okay. So I'll do that real quick. I'll just copy paste some stuff over. And if you have questions, you can put some questions in the chat, or you can talk on the microphone. I'm just going to copy stuff over. I'm going to get rid of the labels. Make sure you do that again. I'm just doing it real quick and copying it over with the label. And then eventually I'll just take that out. So that's always a good rule, because in SPSS, you know how everything is when it's all entered. Sorry. It's just like it has the label of like the column, right? Like NPI scores, and then you'll see the scores. So if you want to do that, it doesn't matter which one's X, which one's Y. Just make sure you copy one variable into one column, or one column into the box here. So don't mix them up. So if you want to write down on your notes real quick, I put in the X values box, Rosenberg self-esteem scale scores. In the Y, I put the NPI, the narcissism scores. Okay, now you're ready to calculate R. So go ahead and click that button. If anything's wrong, oh, look, I forgot to take that out. See, and this is what I like about SPSS and Excel and even this calculator. If something's wrong, it'll tell you. So check whatever is the issue, try it again. Don't beat your head against the wall. Be very conscientious when you're doing statistics. Okay, here's a couple things that you're seeing. The value of R is 0.701. We can round this up because we're still doing 3 significant figures. So when you report this, it's 0.702. Here's an exception. When you report statistics, the only one that does not need the 0 to the left is a correlation. So in APA style, you would report this as, first of all, it's lowercase r equals 0.702 if you're rounding. It would be lowercase r because this is a Pearson's R. A capital R is typically for a regression, and a 0 in front of the decimal. It is correct because it's holding a place, but correlations can never exceed 1. They vary ever unless it's perfect equal 1. So when you report it, you would just take away the 0 from the left. And what I like about this website is if you were to click on this, it might give you some insight into how to report this in APA style. But always check your manual, or always check whatever sources you guys are using, the academic writer database, if you guys are using that. You should always double check that. So if you're interested, why don't you click on that and take a look at that? Okay, so here's a scatter plot. If Professor Chen is asking you to do figures, you could probably copy and paste this into your paper. And look, it actually shows you the calculations. And you can even look up, hey, I don't even need to do the other calculators. It gives me the mean scores for the Rosenberg, the NPI. It tells me the standard, well, might not tell you the standard deviation, but it gives you all the information here. So down here, R equals, and they do the calculations for you, 0.701. Okay, now if you keep scrolling down, it also tells you what this is. It tells you that it is a positive correlation because it's a positive integer. So it's not good. It's positive because the slope of the line is positive. Okay, if it was negative, you'd see that negative sign in front of the 0. Now this one, it says it's a moderate positive correlation. There's a couple of ways to look at this. There are some people who believe that correlations above 0.7 are actually considered strong. So you might see 0.7 and above described as strong. There are some people who are even more, I would say, lenient with this definition, and they think anything above 0.5 is strong, a correlation that is 0.5 and above, and anything below 0.5 is considered weak. So it is either 2 ways typically. Anything above 0.7 is considered strong, anything around 0.5 is moderate, and anything below 0.3 is weak. Or if you go by the very, I would say just a more simple definition, anything above 0.5 is considered a strong correlation, which you guys should know what that is because you took stats. or below anything below 0.5 is considered weak. So I think it's okay to use whatever which way you learned with your stats professor, but remember positive correlations, that tells you the direction, and the number tells you how strong it is, right? And you have to interpret not only strength and direction, but also significance. That is that other part, which is not given here. So this tells you the correlation coefficient between narcissism and self-esteem scores. It's positive, they move in the same direction. If people score higher in the Rosenberg, they're also giving higher scores on the NPI, which makes sense theoretically, right? Because as two constructs, self-esteem is an overall or an evaluation of yourself. A higher score typically is more positive view of oneself. And then most people who have a very positive view of themselves might be narcissistic. Okay, so we're not measuring the personality disorder, we're just measuring the trait, which everyone has. All of us are narcissistic, is to the degree which varies. And this is what this analysis is telling you. If people have lower self-esteem scores, you actually see people who then report lower narcissism scores. So it is another way to look at this relationship. It gives you the interpretations, but remember, you can use the way that this is kind of a way to double check it. Don't copy and paste it. Think about your results, okay? You should always get information, make sure it fits in line with what you know. Ask if you are unsure. Don't just copy paste. The numbers are fine to copy paste, but you should still use your brain to analyze and interpret results, okay? Now, normally we don't actually calculate or report effect sizes, which is what this is down here. That could be something you did in stats, but usually when you're doing research, we try to be very straightforward, and we don't usually ask for effect sizes unless you are very, unless you're really, really, really good at stats. So normally we just ask for the coefficient. Now, we don't know if this is significant, right? We don't know if this is statistically significant. We just know it's possibly a strong correlation. It is positive, but we need to figure that out. So in this case, what happens is you could look at the plot and think, oh, looks like it's the line of best fit is almost, it goes up. So what we have to do is double check that information. Okay, so I'm going to go back down. I just wanted to make sure I wasn't missing anything. Where it says we can calculate the p-value, you can click on this to help you determine significance. And this is what I like about this website. I know that in SPSS, once you get the correlation, it'll tell you that P is less than 0.05 or P is less than 0.01. It tells you in the table, right? In output, everything is given to you. So I would say that's probably the advantage of SPSS, where you don't have to click maybe as much. But again, just in case SPSS wasn't working, your license isn't working, you couldn't get on, you couldn't figure it out, all you have to do is use this. Now, unfortunately, you actually just have to type in the correlation again. So you could just put 0.7016. N is based on sample size, you guys. So to determine whether this is significant, the calculator has to figure out degrees of freedom. You just need to give it its N and it'll calculate it for you. But you guys know how to do that by hand because you learned in stats that degrees of freedom is based off sample size. For a correlation, the formula is n-2. So in this case, you would there's 56 data points. And I'm going to choose 0.05, but I could choose 0.01. The only thing you cannot choose is 0.1. In statistics in psychology, our alpha level at the on the highest end should be 0.05. If you want to put 0.01, that's just making it more stringent, but it's actually the same thing. So it's not like you are making it, you're not really changing the meaning in terms of what we consider significant. But just keep it at 0.05 because that is our alpha level that we typically use. There is no need to make it more stringent. And then you can hit calculate because it gives you the p-value. So this is the r value. I'm just sure everything looks good. And then I'll go ahead and click calculate. And then if you want to do that, you can go ahead and do that as well. You should be able to get the actual p-value. Just look for anything that looks new. Okay, so here's in blue now. The p-value is less than 0.00001. So the result is significant and p is less than 0.05. Now remember, when you report this, the p would be italicized in APA style. Again, don't just copy paste without thinking. be very conscientious, examine what you're looking at. It's really the content that I think this website gives you, like good content, but it's not going to be a thinking brain that can do APA style formatting for you. Like it doesn't know that you should italicize the P as well. So you should always double check everything, but this is significant at P less than 0.05. So that helps you to figure that out. So I know that you learned how to do that way, looking at like say critical value tables. If you didn't have the P value, SPSS does give you the same thing in the output. So in this case, it's just giving the same information, just in a different way. So this is significant at 0.05. If you wanted to click it, see if it's significant at 0.01, which it is, you could do that too if you really wanted to check that. You normally don't report the significance level as an exact value. You would not report P as less than 0.00001. We just report it here. Either P is less than 0.05 or P is less than 0.01. We want to be very concise with our writing. Okay. So it does give you the exact P value though. So if you really wanted to report that, you could. But we still want to stay within three significant figures. P value is the exception. So it is P is less than 0.01. You don't have to add another 0 to the left of the decimal. Those, again, that's another exception. So if you were really interested, I would say click on the link. This is how to report Pearson's R in APA. It's been updated to the new 7th edition. So just be very careful, but it should give you an idea of what it should look like. Now, Professor Chen will give you the examples in your paper, what to follow, but this is going to give you a model of how statistics are typically reported in APA style in general. But again, this is not a thinking and feeling machine. It doesn't update itself like your brain does. You should always check it. So usually you do R and then in parentheses degrees of freedom, the correlation coefficient, which is what they call the R statistic, and the p-value. So in this case, you know, this example, IQ and GPA were found to be moderately positively correlated. Okay, and so on. So you could examine, okay, should be stated to at least 2 decimal places. I prefer 3 total, so I usually ask students for 3. Again, this is not how you should write your paper. This is not from your instructor. This is just some general things to think about, okay? So never just copy paste without double checking. So, but that's what I like about this, like everything's kind of integrated where, you know, you got results and you're like, well, how would it look in APA style? Let me see what it should look like, or what would be a format. And then you click on this and you're like, oh, okay, I can see how it's supposed to be, but I'm going to double check all my other sources. Okay. Now, the correlation coefficient, remember, was under calculators. It's 2 boxes. You pick one variable, put all the data in there, pick the other one, put that and copy it in there. Now, the only thing that's really important to do is it should be paired data. So don't mix up the variables. Like you should have them in Excel or SPSS, and you guys know where the data, usually it's participants go all the way across all their data, and then the variables go through the columns. So make sure that whatever data sets on the first row, that narcissism score, the data set that's on the very top row of the other column, that is that same person's self-esteem score. So just be very careful that you don't have missing values, or that, you know, there's more data in one column than the other. And that is why SPSS can help with that, because there's less likely chances of that happening. Okay, but I still think it's a good idea to just have another tool in your toolbox, right? And you can kind of show someone if they don't have SPSS, but you want to give them something they can use. Or if, you know, when you guys graduate and you don't have SPSS any longer, then at least you have this. Okay. All right. So do you guys have any questions about how to run a correlation and how to interpret a correlation before I move on to how to do a t-test? Or it's either called, well, typically it's called a t-test. Sometimes it's called an independence group t-test. It goes by a couple different names, but a t-test is used for 2 groups only, and it's used to look at mean scores. So I'm just going to wait to see if anybody has questions. What I'm going to do while I'm waiting, I'm going to go back to the Excel file. I'm actually going to look at the Excel file, and I'm going to grab 2 groups. And when you do a t-test, you still have to grab the data, but you have to figure out which group you're grabbing it from. So let's say, for example, I'm going to use the ones on the left side or the right side of the Excel file, empathy scores for birth order differences. So this again is real data, empathy scores between what are firstborn children, middle children, and or middle child, and then the last born. Now, middle child, that's like me. I have one older sibling, one younger sibling, but a middle child is anyone who actually is in the middle of any two siblings. So you could have 3 older siblings and 1 younger, and vice versa. You just need to have one of each. That makes you a middle child. You don't have to be the median child, which is like smack dab in the middle, even though I am smack dab in the middle of my siblings, but you don't have to be. So a later born or middle child is anyone that has 1 older and 1 younger sibling. Now, if you're like Professor Chen, who's I think she's the youngest in her family, so she's the last born, she has only older siblings, no younger. So sometimes they call it the last born or the youngest sibling. Obviously, the firstborn, that one's pretty straightforward. So
can you tell by our personalities
that we're so different?
I'm the youngest.
And she also does remind me a lot of she and my younger brother have a lot of the same really good qualities. The middle child, though, oftentimes on empathy questionnaires can score higher than the other two in general. Could be within the family, could also be just in general. The theoretical explanation is that middle children are always stuck between their siblings, and they learn how to sometimes mediate fights. And they often have to take on the point of view of the other sibling most of the time. They have to learn they've always had to share with their older sibling, and then they have to share with the younger sibling. And they're often taught to be very cognizant of their older sibling. Let's say, oh, she's your older, sister, show her some respect. And then I have a younger brother, and then I was always told, oh, he's younger than you, just let him play with your toys. Okay. So I was always, being a middle child, I think you are always in a position, it can be very common, that your parents often help you cultivate that. It might seem annoying when you're younger, but they cultivate that because they often help you take on the perspective of your older sibling and then your younger sibling. So I had to let my sister have her time because she was older than me and I couldn't follow her around. I had to give her, space. And then I had my younger brother who I had to take care of a lot, and because he was younger than me, so I had to do that. So I think if you kind of feel like your family structure has birth order differences, I think it has an interaction between your gender, it could be your age, it could be, your ethnicity, because there's a lot of cultural stuff around the way family works. But birth order differences are really interesting because the wider the gap between the children, that actually changes everything. Even though like you're a middle child, you could be more like an only child. So even though Professor Chen is the youngest in her family, I say she had a lot of time sometimes being the only child in the family in some circumstances. She has brothers, right? But she also had a lot of time alone with her grandpa. So that in that way, it can kind of make her like an only child. She got a lot of sometimes if you have a lot of space between your siblings, okay, you can sometimes be raised or have that experience of being an only child, even though you have siblings. So I want to say that when you have birth order differences, if you just ask it nominally, like, this is actually ordinal because it's first, middle, and last, and it's ranked. I don't think that tells you a whole lot. I think it tells you what group I belong to and what group she belongs to. But I would actually argue that Professor Chen is probably really empathetic, a lot more so than I know of a lot of younger or the youngest in the family. Okay. So we're not saying that this is a cause or the only cause. What we're saying is it's a grouping variable. There are some people who are like me, who guys are middle children, so we share common experiences. And let's see if that grouping that, what group we belong to might impact something like empathy. So it might impact something like personality. But you got to be very careful when you choose birth order as a variable. Should always be a third variable, should never be one of your major ones. Because you should also take into account how the length of differences between the siblings. If it's been, the literature says if it's been 7 years, if there's a 7-year gap, it's like you're starting over with like a first child. Okay, so I'm just making sure that everybody is on the right page. So I'm going to click on the t-test calculated for 2 means. This means I have two groups that I'm looking for. It's independent, so I'm going to choose from the data set firstborns and then middle children or laterborns. And then I can only do groups at a time. So if I need to do, if I want to incorporate how laterborns or the youngest children, I will just do a separate one, okay? So I'm choosing the same variable. I'm going to choose the empathy scores, but I'm going to, again, make sure I only choose one group at a time. So again, I'm just making sure that I have all the criteria met. I have two groups and only two. I'm looking at a numerical variable. Yes, empathy scores are numerical here. And I have two independent. Yes, I have one firstborn and one laterborn or middle children. Now, what's interesting is that if you just went by the definition laterborn, that would include the youngest children because they're just born later or after the first. So I'm going to be very clear. I'm going to use the middle children and the firstborns. Okay. And they should have the same variance. So you should check like the means and median and mode and to see if it's a normal distribution. You'll make those, you'll check those assumptions ahead of time. But I'll just show you what you should do if using the statistics. And again, the website it's just kind of slow. It doesn't always recognize that I'm trying to click on it. But it should look very similar where you have the two different boxes that you're going to put the data in. Now, don't be thrown off when it says treatment. Usually the treatment refers to the fact that most drug studies have two groups. They look at the placebo and the group that gets the medicine, right? And so you can correlate or you can relate that to like the vaccine testing. So you could think of one group, treatment one is one group and treatment two is the other. Again, doesn't matter. It just matters that you click into one group and put all their scores, like say the firstborn, go to the second box and then choose the group, like say middle children and put their scores in. Don't mix and match the groups. What we're clicking into is the same variable. So we're just grabbing the empathy scores. This one, they're not paired data. So they don't have to line up. Like it's not that the first line in the firstborn matches up somehow to the first line in the middle child column. This is totally different. Okay, so, but you do the same thing. So I'm going to go ahead and I'm just going to grab the data that I have in that data set that you guys got as sample, and then just copy and paste it over. Some of this is 3 significant figures, some of it's only 2. And so what I'm grabbing from that data set, you might not be able to see what I'm doing, but I'm just grabbing the empathy scores from the first group, treatment 1 or group 1 was firstborns. This one, group 2 was middle children. And we're just testing the hypothesis that birth order differences can be shown. It's not a cause and effect statement, although if you were doing an experiment, you would use this. You would use like a very similar test. So this is 2 different groups on the same variable, okay? It's not 2 different variables. It's 2 different groups looking at the same variable, but grouping them by whatever nominal variable you have. So in this case, it's firstborn versus middle children. The groups can be anything. It could be males versus females. It could be part-time students versus full-time students. The group just means that they belong to this particular, set of rules, and you're not going to mix them up. Okay, so the data set was, she would have sent it to you this morning. If not, you can probably check it out now. Okay, now it's very, it's also common to make sure that you have the same amount of group participants in each group. So you would want to have, in an ideal world, 30 and 30 in each group. At minimum, you should have 10 and 10, okay? If you have, let's say, only 10 firstborns and 12 middle children, that's usually okay. But we don't want to have a situation where you're comparing 20 firstborn children to 100 middle children. That will create a lot of discrepancies in your data. And then we have to figure out if we can trust the data. So at least 10 cases, 10 people per group. Hopefully they both follow a normal distribution, and we're just looking at birth order, so it doesn't matter. You probably would want to do something in terms of having an equal number of male and female. That's not the variable, but you don't really want to have a confound. You don't want to have all your firstborns be male and all your middle children be female, because with empathy, that that's going to affect empathy scores. So hopefully we have a mixture here, although we're not worrying about gender at this point, but we're going to assume that we have a good mixture. It's 0.05 alpha level. It's a 1-tail test. And again, you should learn the reason for that in your stats class, but always use a 1-tail test in research methods because you're testing a specific idea. you have a hypothesis. And when you test a specific hypothesis, those values will only be found in one tail of the distribution. So my hypothesis is that middle children are more empathetic than firstborn. That is my hypothesis. So I choose the one tail. Okay. And again, if you need a review, open up your stats book, look at your stats note. If you don't understand why that's important, the theoretical, the actual conceptual reason right now, it doesn't really matter. We're just telling you how to do your stats. So in statistics, in psychology, always alpha level 0.05, always a one tail test. Okay. And then what you'll do is you'll click the calculate button and then, wait for the magic to happen. Okay, again, they actually do the calculation. It gives it to you. So the mean score here, 5.52. Here's the standard deviation, or it's probably the variance. And so the numbers are given to you, but scroll down because it'll show you everything you need to report in your paper. Shows you how many people in each group. It shows you the mean score for each group. It also shows you the standard deviation, which is below, to the variance, which is below that. Okay, and look, it shows you the calculations if you really wanted to double check those. But your t-value is it's 3.31. You don't have to round this because 3 is more than 5. So when you would report this, 3.31, because we have 3 significant figures. In this case, you do have to report anything that's to the left of the decimal because t-statistics can be greater than 1. They're often greater than 1. So they can be greater than 1. It's not the same rules for the correlation. And here's the p-value, 0.0017, which is less than 0.05, which is also less than 0.01. So these results are significant, and they're significantly different. And this is not the same as strong, weak, and positive and negative like a correlation. What you want to look at is which group has a higher mean score, which often the way that you interpret that is that they have more of. They report it, they have more of. So in this case, if we look at the means, the middle children, which was group 2 or treatment 2, has a mean score of 8, almost 9, where the firstborn children indicated that their score was 5 on average. So it is based on my hypothesis. The data supports my hypothesis that middle children on average report themselves as being more empathetic than firstborn. And then if you wanted to look at the difference between middle children and laterborns, you can just rerun the analyses, grab the values from that third column and make sure to put them into the formula and then run it and see what you get. So the only restriction with the t-test is you can only do 2 at a time, but you can do multiple t-tests. Now, I know that this minus sign might throw you off and you might think, does that mean anything like it does in a correlation, which would signify a negative correlation? With a t-test, that you should always look at the absolute number. So in this case, you would just report it as 3.31. You could report it as negative 3.31, but you don't need to interpret it as meaning anything. The only reason it's like this is because the mean score of the firstborn, which is about 5, was subtracted from the mean score of the middle children, which is 8. So you end up with a negative number. So it doesn't really mean anything. Okay, so don't let it throw you off. Remember, you could always look up examples of how t-tests are reported. Again, that's why I like this website, because you can just click on the follow-up, like, oh, see how it's reported, and then you get an idea of if it really means anything. And a lot of times it doesn't. A lot of times we like to report the absolute value, so that just is typically the positive value. And then again here, they found that coffee drinkers spend more time awake than the normal. But it's typically comparing one group to another group. Okay, control to the treatment group, or male versus female. In this case, we did firstborn and laterborn. You can do a t-test that is like pre and post, or a paired t-test, but that's going to be in a different situation, not the ones that you're measuring for your project. It's going to be the independent samples t-test every time. Okay. Now, so how to report it's pretty much the same. But what if you really wanted to do all 3 together? So again, the correlation, your 2 variables must be quantitative. It's like narcissism score with self-esteem scores. But what if you had groups? What if you wanted one variable, like say empathy, and you want to look at birth order, so firstborn versus middle children? That's when you'd use a t-test. What if you wanted to put all 3 of the groups, or if you had 3 or more groups and you wanted to put them all together all at once? Then you use the ANOVA. So in this case, you could grab the firstborn, the middle children, and put the scores for the later born all in their own column. And I'll just go do that real quick. And then you go ahead and run you'd run the t-test. Oh, sorry, it's an F-test for the ANOVA. So you would go ahead and do it like that. I'm gonna get rid of the labels in a second. So use the ANOVA if you have 3 or more groups. Otherwise, use the t-test. Now, what happens if you made a mistake and you used an ANOVA one way for 2 groups only? That actually is fine. You just have to have a minimum of 2 groups. But typically, an ANOVA, analysis of variance, is used when you have 3 or more. So I think it's sometimes easier if you make sure that you know the differences or when it's used or why they're used. Oops, no, don't do that. Okay, so a one-way ANOVA is the same thing as a t-test.
If you wanted to leave the labels in just to make sure you have it written down so you don't confuse which group you've put under treatment 1, 2, or 3.
So always, write notes. That's a good point. If you're saying to yourself, oh, treatment 1, that's where I put the firstborns. So like I said, don't just do things willy-nilly, you guys. Don't just be like a robot and copy paste stuff. You really got to think about it. Take your notes. Make sure that you're paying attention, be very conscientious, okay? I don't ask students to be perfectionistic, but I do need you, I think it's a good rule just to always be aware of what you're doing. So sometimes students will, like, I think it's very easy that when you're listening to a Zoom, you just kind of zone out. You're like, you have it on, but you're like, you're on your phone or you're watching TV. And then I'll have students emailing me right after asking me the questions that I answered in Zoom, because a lot of times they're just not taking notes. But I just think
if you're paying attention right now.
Just pay attention to what you're doing. Be cognizant. Be mindful. Okay. So here's what an ANOVA normally looks like in SPSS. And so we're looking for the F value, and the F value, typically if it's greater than 1, it's going to be significant. It doesn't tell you that, but look, we have mean scores, we have standard deviation scores, we have how many people are in each group. So all I'm looking for is whether it's going to tell us the significant, and it does. It tells us the F ratio, the F value, the F stat is 4.56. So we could round that up. Oh no, we don't. We just report it as 4.56. P value is less than 0.05. And here it's not exactly less than 0.01, because if you look at the p-value is 0.018, that would be technically 0.02. So we would just keep it as 0.05 less than. Now, in SPSS, when you run an ANOVA, what it also does is it runs the follow-up t-tests, which are called Tukey t-tests typically. And that's what the t-test stands for. But this is a follow-up t-test, because once you get an ANOVA that is significant, the 3 groups differ on empathy scores, it's going to tell you where the differences are. Is it between group 1 and 2, firstborn and middle children? Is it between middle children and later borns, groups 1, like 2 and 3? Could it also be the like firstborn and the youngest children? Okay, so see, that's what I'm looking at, these pairwise comparisons. So we're still looking for the t-test. I know it says Q, but that's just the same thing as a t-value. We're looking at the p-values here. Which ones are less than 0.05? The only one that is less than 0.05 is the one that we talked about earlier, between first and middle children. Now, if you look at, between first and the last born, there is a difference, and later lastborns are more empathetic than firstborns, but the difference is not significant because P is greater than 0.05 here. And again, if we look down here, later borns are more empathetic than firstborns, but the youngest children compared to the middle children are still significant, or still higher on empathy, but not significantly. So there is a difference, but it's not a statistical one. So a ANOVA, if significant, will tell you there's at least one group comparison that is significant, and we found it here. All 3 could be significant, or just 2. The only basic thing that you can assume is if if an F test, if an ANOVA is significant, there's one group comparison or one combination of group comparisons that is significant. Not all pairwise comparisons have to be, just there is one significant group difference somewhere. And you wouldn't know that just by looking at the F test. Like you won't know which one is significant. You could just look at the means and you could assume, oh, look, mean scores 8 is, 8's greater than 7, 8's greater than 5. The t-test or the 2P test, the follow-up, the post-hoc tells you exactly. Okay. So, but you got to be careful, because if you notice when we did the t-test, the value was like 131. It's not this exact same as this Q value. So you couldn't use these to replace the t-test, but this does tell you, oh, here's a significant difference here. So I would, you guys, those are the 3 that typically my students use. And at this level, those are the 3 that you would probably use for your paper. But if Professor Chen lets you do like a chi-square, the chi-square is on the list and you can kind of figure it out. I think you have to type the values in. If you know how to do a linear regression, there is that option in the calculator. So I'll go ahead and go back to that list. There's a lot of them. And remember, it doesn't replace SPSS, but it's pretty close. For it being free is actually, it's a pretty, it's pretty comparable. But again, I think the biggest questions is, do I have to know? I think your instructor is just being really nice and allowing you guys to learn something different and giving you the opportunity to learn this new skill, but also a new website. You could do literally almost the same thing without having to have a license or log on. The only thing you need is an internet connection. Okay. And so I know that that's important for my students to have equity. And I know that's important for Professor Chen as well. That you guys have all these available. No, I know. I'm like,
go ahead.
Yeah, get out of my way. Okay. Sorry. I was like trying to get it out of my way, but sorry. I think I accidentally ended the poll, or actually I answered the poll. So there's all kinds of things you can do here. You just have to read about it. So if you're not sure what an independent samples t-test, just Google that. What is an independent samples t-test? And again, if you already had the values, like if you had the t value, the r value, you could always just plug it into, for examples, if you had the correlation coefficient and you just needed to get the p value, you would click on that. So you could double check, like, let's say you got a correlation from SPSS and you want to make sure it's significant because you can't really tell based on looking at the output. You could just plug it in here. So remember, this is pretty straightforward and it's pretty user friendly. So I would say if like you don't remember anything that I taught you today, if you just kind of spent some time looking at it, I think you'd be able to figure this stuff out on your own. But please be very cognizant, okay? Don't just like copy paste stuff and do things willy-nilly and not pay attention to what you're supposed to be doing. But I think it's, what I like about this, you could do the quizzes, you can kind of test your knowledge. There's actually tutorials that actually, it does tell you how to use the website. So these would be for fun, you guys. If you did the quizzes, you wouldn't get points or anything like that for the class. But I think it's always like, okay, how much do I know about correlations and t-test and all that? Okay. Yeah, so I would say, yeah, if you want to just mess around with this website because you just wanted to learn more, but you have SPSS, I would always say just go with SPSS. Go with what you know. Don't feel like we're forcing you to do something. But look, this also has a lot of cool things that's like integrated into SPSS. And again, this is why I also like this, because the people who made up this website understand that most of the students will have access to that, but they're gonna, give you a free way to do your data if you need one. So under the tutorials, which is cool because they have, you can also, if you have, I guess, this version, you can click on this, you can use that. Okay. But I think that's the main 3 that you're probably going to be using in this class. I know that I don't, we're not the exact same. We don't teach the class the exact same way, but that's pretty standard for this level of class. I'm going to go back, is to use those 3 along with the means and median and mode, the standard deviation and all that. Don't forget all that stuff really matters as well. But if you go to calculators, that's kind of all where you need to go. And then choose the one that is appropriate. And if you're worried or you're not sure, just ask your professor. I'm not sure if I should use a one-way ANOVA or a two-way ANOVA yet. You should always use a one-way to start, because if you're doing a two-way, you're not in the right class. A two-way would probably be in the upper division experimental. So what I think is a good piece of advice is that no matter, like, I know some of you have had a lot of extensive, training SPSS. This is undergraduate. This is the first research methods class you're supposed to take before the experimental, which is considered upper division. You need to have a good foundation, all the basic and simple things in stats and in research. Then you can move forward and do all the, maybe more exciting stuff or more difficult stuff. I think the issue is students always want to skip to that exciting or more difficult stuff without having a very strong foundation in just simple correlations. Like, you need to learn how to do correlation, interpret that before you can do a linear regression. Before you can do a MANOVA, a multiple variance of analysis, you should definitely do a one-way. Okay, so this is really just to help you practice skills that you learned in your stats class, to use them again until you feel very comfortable with them. Then guess what? When you take experimental with, Dr. Bui, she's going to make you do all the other ones, or the different ones, and you're going to build your toolkit. You're going to be able to not only run a correlation, run a regression, not only do a t-test or a one-way, a two-way ANOVA, etc. Okay. So that's all I wanted to show you. I don't know if anybody has questions about anything or wanted me to show something again, but the data set that Professor Chen linked with this website, I think in an announcement this morning, you guys practice it. I mean, if you do something wrong, it'll just say, hey, you did it wrong. And then you just kind of figure out what you did wrong. Maybe you put words where you're only supposed to put numbers, or maybe you copied the same data into two different boxes. And then you just kind of practice, you guys. If also take screenshots. Like, if Professor Chen wants your proof that you did something, just take a screenshot of the outcome. And that could also be good for you because you can double check it. You don't have to keep running it. You could always just take the screenshot of the web page.
Feel free to keep all these notes.
That's it for me. I don't know.
Oh, feel free to keep all the notes from this too, because all of you, I believe 15 out of 16 of you said that you wanted to go to grad school. And when you're in grad school, they no longer teach you these steps over again. So it's expected that you already know how to do these from the basic levels up to upper division experimental psych. So keep these notes with you because it won't change. This social sciences statistics calculator website, it's the bare minimum, but it's also something that's going to you could come back and practice with even between schools, between classes, between terms. So thank you. Whoa, the screen's shaking. Thank you, Professor Keogh. Everybody good?
You're welcome. And I can answer questions if anybody has them.
Yeah, so a lot of you wanted to express to me that you wanted to do pet surveys, and I don't know enough about pet surveys, but Professor Keogh's done a lot of this with many of her students. I know that I think one of her classes actually, her students went to do a poster session, right, on video games. Is that what they did? So any of the really exciting topics that you're thinking oh, I'm thinking about this variable. I'm more tried and true, keep it simple, personality test or MMPI or any of those sub skills that have to do with clinical, depression, ones that have been around for decades. But she's more up to date on all the new exciting stuff that she lets her students do. Is it me or is the screen kind of freaking out a little bit?
It's just the ads, I think. Yeah.
Oh, okay. All right. Well, but yeah, so if you don't have any questions, I know I haven't had a chance to look at your variables as they were due last night. Even if you're still kind of working on it, I will accept it late through tonight, just to kind of, it's really just so that you had a chance to do it. And then when I give you your feedback, I'll tell you that sounds great, go ahead with it, or you need to tweak a little bit of this, or I'll help you to make sure that your variables are ready for you to actually make into survey items. And then we did this class a little bit earlier, but I'd rather you have this material now, and again later after you have your data, than to just have you thrown into the data a few weeks from now. So no questions, everybody's good?
I'll just say that if you're in my class, like social or history, you can ask me questions about your research methods. I might not know exactly the answer because I'm not your professor. But I'll be more than willing to help if you need like some guidance or need help looking for something. That's fine. But even if you're not in my class or you've been in my class before, if you still have my email, just shoot me an email. I'm always willing to help students excel in research methods because I know it's the class that's really depending on like to graduate or to transfer for some. Well, you guys have already transferred if you had to, but it's the one class that really scares students. And it is not scary, at least it isn't in my opinion, but I know some people can get very overwhelmed and intimidated by it. But I think research is really, really fun. And you guys have everything at your disposal. You have the academic writer database, you have the psych test database, you have Professor Chen, who's always willing to help you. She's always available. So don't handicap yourself and make this, like she said, don't make it more difficult than it has to be. And you're not at the point yet that you are analyzing your data. You might not even collected data, but this is a good kind of like segue into what you need to have. And so if you're really struggling, like, what am I going to be doing? Well, I had 2 different scores. I had real data. I measured 2 different variables that were related, but they didn't, they had a little bit of overlap, but they were, for the most part, it made sense to see if someone who has high self-esteem might also be a bit narcissistic. And it's always grounded in the literature. You can always look at things like pets if you want, like she was saying. But again, just my best advice, you guys, is always do the reading on your topic. Always look at the databases and have a good foundation before you choose a topic or kind of go further. You don't want to go into something blind, okay? And you might have a really strong feeling like, I really want to do X, but you know what? This class, you might not have the resources or the time. So find the topic that you're interested in that Professor Chen says is doable, and you'll find somewhere in the middle, okay? And then you'll be doing experiments if you take the upper division and you're going to go to grad school. There will always be time to do that big, amazing project that you really want to do. But just keep in mind, this is the undergraduate level. This is like the first time that many of you are doing research. Don't take on too much more. Don't take on too much, okay? Because it's going to stop you from succeeding at the very end. Okay, so that's all I have to say, but thank you for letting me, come in and talk to you guys. I know some of you guys already know me, but I've never had you guys for research methods. So thank you.
Thank you so much. And I know you have to go, so you can go ahead and log out, and you should have like all the information, and we'll talk later.
Okay. Bye, Kate. Okay. Yeah, we'll talk. But bye, Kate. See you in class, I think later this week, right? Okay, I'll log out and then you guys can just send me emails. You can get my email from Professor Chen if you don't have it.
We don't want to bother you. You're super busy too. Thank you.
Okay. Bye.
Okay, so bye. It's not my screen that's sharing, so I don't know how to like.
Oh, sorry. So I have to stop the share because if I don't, then you can't do it.
Okay.
Okay, I'll eventually leave.
Okay, sounds good. Okay, so for now, I'm actually going to, let's see, I'm gonna like stop that recording so that you'll be able to have that.